Our Magic of Materials project investigates the inner workings of a pop-up toaster. The first electric toaster was invented in 1893 by Alan McMasters in Scotland. It required someone to manually flip the slice of bread over. Albert Marsh's 1905 invention of nichrome alloy was used to heat the 1909 toaster patented by Marsh and George Schneider in collaboration with General Electric. Then, in 1919, Charles Strite of Minnesota decided to add springs and a timer to the nichrome wire heated toaster to prevent burning. The double-sided Toastmaster combined all of those components in 1926, creating a toaster similar to the ones distributed today. The modern pop-up toaster has a fairly simple design. The user can insert bread into the top slots. Then, by compressing a spring down, current begins flowing through nichrome coils, generating heat quickly. Through infrared radiation, the heat causes the outsides of the bread to brown. There is a dial that allows the user to decide how long the bread is heated, which correlates to how toasted the bread gets. Once time is up, the spring mechanism is released, the bread pops up, and the heat-producing current is cut off.
The outer casing of a toaster can be metal or plastic. Within this structure, mica sheets wrapped in nichrome wire create the two slots that heat the bread. Each slot has a metal spring-loaded tray used to raise the toast when the timer runs out. The metal lever attached to the tray attracts to an electromagnet on the circuit board and initiates the current flow. This magnet is released when the capacitor on the copper wire circuit is fully charged, causing the toast to pop up. It's been almost 100 years since the modern toaster was invented, and not much has changed. Because nichrome is inexpensive and its unique properties serve the purpose of the toaster well, better material options have not been found. However, specific property needs can be met through a range of alloy composition variations. The future of this object would involve creating something new, rather than adjusting the common toaster. For example, laser toasters and hot air gun toasters that can print images on bread have been built in labs, but the cost is too high for commercial use.
The nichrome alloy, originally called chromel, was invented by Albert Marsh in 1905 at Hoskins Manufacturing to be used in heating applications. It is most commonly composed of 80% nickel and 20% chromium. This specific mix of metals causes nichrome to have very useful properties. First, nichrome is highly resistive, so it generates a significant amount of heat when current is run through it. Also, unlike most other resistive metals, when heated, nichrome creates an outer layer of chromium oxide, which prevents oxidation. With that, nichrome does not break or become brittle at high temperatures, which means that it can be heated and reheated many times without needing to be replaced. The production of nichrome includes the melting together of nickel and chromium, hot rolling the mixture, then acid pickling and annealing it. Next, the wire is drawn out and cold rolled before being annealed into the final product of nichrome wire.
Nichrome is used in a variety of objects because it is cheap to manufacture and has a high mechanical and creep strength, meaning it has a lower tendency to deform under the influence of persistent stress. It is most commonly used in heating elements. Other applications of nichrome wire include hair dryers, e-cigarettes, heat guns, hot wire foam cutters, tooth fillings, fireworks, internal ceramic support structures, and motorcycle mufflers. The invention of nichrome wire inspired the development of the modern toaster that we use to this day.